Guys, good afternoon, good morning, good evening, depending on the location of the globe where you are viewing us from. You are welcome to our class for today. And this is Nobel Science Tutors Online, and I remain Otobo Michael. So for today, we are going to be looking at the relationship between the universal gravitational constant and then acceleration due to gravity. That is capital G and small g. We started discussing gravitational field, so we are going to look at the relationship between the constant uh, universal gravitational constant G, capital G, and then the small letter g, which is acceleration due to gravity. So okay, after which we will now solve some problems that will relate the two variables. All right, so please get your writing materials, your biros, your lab calculators, your notebooks, your writing pad, just anything that you need to write, right? So that you can flow along and solve some problem. But before we go to our class, please, if you have not subscribed to this channel, what are you waiting for? Please subscribe to this channel, give us a like, give us a thumbs up, help us to share this video, and then click on the notification bell if you are just visiting, so that whenever we upload a new video, YouTube will notify you. So that okay, we hope to give you the best in physics. You can reach us via the WhatsApp number showing on your screen, or you can also join our WhatsApp chat group. Click on the link to any of the videos and then it will take you straight to the video that I like. We have tried to segment all the videos into the various topics that are in the West African School Certificate Examination curriculum and scheme of work. So once you click on any video, it will take you straight to the topic and then you listen to the video. Okay, please try as much as possible to watch our videos and introduce our channel to your friends. So having that said, welcome to our class and I hope you are ready. Let's go straight to our class for today. Relationship between gravitational constant and acceleration due to gravity. All right, so from our Newton's law of universal gravitation, we have this equation that the force of attraction between two masses is equal to G m1 times m2 all over r square. Okay, so these are the two masses. This is the universal gravitational constant and that is the distance between them. Okay, so this is what we had from our um, initial discussion. Okay, so if the attraction is between the earth and the mass, if it is between the earth and a mass, then the law will now become, or the equation will now be this. Okay, so this is the mass of the earth and this is the mass of the object. Then this is the universal gravitational field and this is the radius of the earth. Okay, this is the radius of the earth respectively. Now we remember that from our equation of force, we remember that the weight of an object of force is equals to what? mg. Can remember this when we discussed force of gravity. You can remember this equation. So from there we say that g is equals to force all over unit mass. Okay, so g is equals to force all over unit mass. Now if we compare this to what we have in this equation, we can actually write this equation, this particular equation, we can write it as we can write that equation as F over M equal to G times mass of the earth all over the radius of the earth raised to power 2. Okay, and that is exactly what we have here. You can see it here. Okay, so you can relate this like this. This is what we have here. Okay, fine. So if you look at this, find out this is equals to G. It's equals to G. Okay, so and that is what we have here. So this, which means that G is equals to force per unit mass, or G is equals to the mass of the earth all over radius of the earth square multiplied by universal gravitational constant. So the relationship between the small g and big G is this particular equation. So from this equation, we can calculate the mass of the earth if we are able to measure gravitational acceleration and gravitational constant accurately. We can calculate the mass of the earth from this particular equation. It's just for us to make the mass of the earth the subject of the formula, and then we can solve for the mass of the earth. Is that okay? So this is a relationship between acceleration due to gravity and the universal constant, or gravitational universal constant. Okay, so this is just it, and then right away we are going to solve problems that explains this better. So let's go straight. Sample question 1. Determine the mass of the earth if the radius of the earth is approximately 6.38 times 10 to the power 6 meters, and G is given to you to be 6.67 times 10 to the power minus 11 Newton meters square per kg square, and G as related to gravity is given to you to be 9.8 meters per second squared. Okay, so first thing that you do is that you are looking for the mass of the earth, and we are giving that as gravity is equals to G, mass of the earth, all over radius of the earth squared. Okay, so from this we can make mass of the earth the subject of the formula, and that gives us G times the radius of the earth squared all over capital G. Okay, so this is the equation that you need to solve this problem. Having gotten this, what you now need to do next is for you to now bring out the values which will be given to you. G is given to you. You will be given, this is the radius of the earth that is given to you, and then this acceleration due to gravity. So just substitute into this equation. So I have that your G is 9.8 multiplied by the radius square, which is 6.38 times 10 raised to power 6 all squared. This is squared divided by gravitational constant, which is 6.67 times 10 raised to power minus 11. Okay, so once you do that, you are going to have calculate that one. Punch, if you use your calculator to work all this out, you will have that the mass of the earth, ME, is equals to 5.98 multiplied by 10 raised to power 27 10 to the power 24 kg. Okay, now for you to make this calculation easy, you can actually break this part out. Is that okay? You can break it down so that it will be easy for you to solve. Okay, because sometimes you find it difficult to punch this out in a calculator. So let me just show you the breakdown so that you will not like have much problem. So you can write it that way. Okay, multiply by 6 times 3/8 times 6 times 3/8 times 10 raised to the power 6 times 10 raised to the power 6, okay, all over 6.67 times 10 raised to the power minus 11. So I think with this it becomes easy for you, right? You can multiply this out, then you know the rule that governs this in indices, then you know the rule that governs division of indices, and then your answer will just come out readily like this. Okay, so you just have a ready answer like this, so I won't have much problems. All right, so this is how to go about solving these problems, and then this will be your answer finally, 5.98 times 10 to the power 24 kg. So you can punch that out from a calculator, and then you get your answer readily. Okay, so thanks. Let's go to another question. So this is question number 2 on this. This is question number 2 on this. This one says that the magnitude of the gravitational attraction between the Earth and a particle is 40 Newton. So this magnitude is the force. So force is equals to, is given to you to be 40 Newton. Okay. Then say if the mass of the particle is 4 kg, so mass is equals to 4 kg. Okay, 4 kg. Calculate the magnitude of the gravitational field intensity of the Earth on the particle. Okay, so I didn't mention all this, but gravitational force or gravitational acceleration is also known as gravitational field intensity. Okay, so what this question is just asking you to do is that find the force or per unit mass. That is, find this force per unit mass, which is equals to gravitational force, and this is also known as gravitational field intensity. So just put those values down. You say 40 over 4, and this gives you 10 Newton per kg. That's all. This is a jam question, so that's all. It's equals to 10 Newton per kg. Okay, so this one is brief and direct to the point. I'm bringing on this question so that you see areas where questions can be twisted and how you can approach them. Okay, so you know how questions can be treated and then how you can do what, approach them. So thanks. Let's go straight to another question. Let's go straight to another question. All right, so let's go to another question. Thanks. I hope this one is clear and you don't have any issues with this. Okay, so this is another question too. As I said, this particular lecture, we'll be solving some relatively numbers of questions so that you know how to go about them when you want to solve, in case you come across these questions in your examinations. Okay, so this one says that the Earth is 4 times the size of the Moon, and the acceleration due to gravity on the Earth is 80 times that of the Moon. Find the ratio of the mass of the Moon to that of the Earth. Find the ratio of the mass of the Moon to that of the Earth. So what we'll be looking at here is mass of the Moon and mass of the Earth. Remember that we said that mass is equal to, sorry about that, let me just make it clearer. Mass is equals to what? G r squared all over capital G. I hope you don't forget this. So have this at the back of your mind while we walk through this question. So in this particular question, you are giving the size of the Earth and the size of the Moon, and then the size of the Earth and the size of the Moon is determined by their radius. Okay, so the radius of the Earth, if RE is equals to that of the Earth, and then RM is equals to radius of the moon. Okay, so the statement of the question is that then we have if GE is for Earth, that is acceleration due to gravity is for the Earth, and then GM is for that of the moon. We know that G, universal gravitation, remains the same, so this one is not changing. Okay, so this one is not changing, as the universal gravitation remains the same. Okay, so this is G. Now, from the statement of the question, we are told that the radius of the Earth is 4 times that of the moon. So as the Earth is 4 times the size of the moon, so which means that if this is RE, then that of the moon will be 4. RE will be 4 times RM. That is what this statement means, and this one can be written as RE all over RM equals to 4. Please follow me as I try to interpret this question. Is that okay? So this is what we know now. They also told that the acceleration due to gravity on the Earth is 80 times that of the moon. So which means that G, that of the Earth, is equals to what? 80 times G of the moon. Okay, so this is it. So this one too, you can also write that G of the Earth all over G of the moon equals to what? 80. Okay, so this is what we have gotten. If this is 1 and this is 2, for your reference purpose, so that we can refer to them as 1 and 2, just take it like this, as 1 and 2. Now from this initial equation that we wrote, we can actually write that for the Earth, we can write the mass of the Earth, ME, is equals to what? The GE all over RE squared over capital G. Then mass of the moon, we can also write it as mass of moon is equals to GM RM squared all over capital G. Okay, because this is the equation. Now, having written this, what do you need to do is, they said you should find the ratio of the mass of the moon to that of the Earth. So write these two equations in form of ratio. Okay, so we have M, mass of moon, to mass of Earth is equals to, mass of moon is this, it's equals to G moon arrow moon squared all over capital G. Okay, so you are going to divide by the mass of the Earth, and you know that when you divide this, you are supposed to now have, so you do your conversion there, so you have G all over. You know that when you write this one, if you write this GE, if you write this fraction under this, and you want to make them, you want to do your mathematical interpolation, this G would become a numerator for this particular equation. So this will become GE times RE squared. Okay, so which means this and this can actually cancel out. So if this cancel out, you are going to have this as your ME, mass of moon to mass of Earth, we becomes G moon arrow moon squared all over G Earth arrow Earth squared. This you can also write as G mu G earth multiplied by arrow mu arrow earth all squared. This is squared. Now look at what you have here. Look at what you have here, and compared to this, compared to 1 and 2. If you compare this, what you have here now, to 1 and 2, you find out that this is arrow m over arrow e is equals to 4. So this tells you that the arrow m over arrow e here, this is arrow e over arrow m, and this is arrow m over arrow e. So which means that this should be the inverse or the reciprocal of this. Then this is gm over ge, and this is ge over gm. So this should also be the reciprocal of at. So once you know that, it means that this will now become 1 all over at multiplied by 1 all over 4 squared. Okay, so when you work this out, you have 1 all over 80 multiplied by 1 all over 16. Okay, so sorry, I don't have more space here again, so I have to move this up here. Sorry about that, but I hope you are following. So I have to move that up so that I will have some space up here. So this way I have space, so I can just write that 1 all over 80. I can play around here times 1 all over 16. Okay, 1 all over 16. Okay, 1 all over 16 there. 1 over 16. So that gives me 1 all over, if you multiply 16 times 80, that will give you 1280. 1280. Okay, so the ratio of the mass of the moon to that of the earth, m earth, m moon, is equals to 1 all over 1280. So in the form of ratio, this will be 1 to what? To be 1 to 1280. Okay, so that will be it, 1 to 1280. So this will be your final answer. The ratio is 1 to 1280. So this is the ratio of the mass of the earth to the mass of the moon. I hope you followed. Okay, so please don't mind me, just take this up and then you follow from here. Okay, so you see how it started relating the radius of the earth to that of the moon, and then the mass, the association to gravity of the moon to that of the earth. The questions are, the earth is 4 times the size of the moon. So where you have the earth, the moon should be, the earth is 4 times. Okay, the earth is 4 times the size of the moon. And then the association to gravity of the earth is 80 times that of the moon. Okay, so if you have the earth here, then the moon should be, okay, so the moon should be 80 times that of the moon, and then you get your informations this way. Then from there, use the equations and then just do this simple mathematical solving and get this, relate your equation to what you have here, and then your answer comes out readily. Okay, so thanks. We'll go to another question. This is another question too that we also still need to solve. All I'm doing is to try to make sure that you have understanding of what these questions are all about. Okay, so this is another question that looks like the one that we just did now, but this one is in another form. Okay, this one is another form. This one says that the radius of the moon is 1/4. The radius of the moon is 1/4, and its mass is 1/8 that of the earth. Okay, so if the accelerating gravity on the surface of the earth is 9.8 meter per second squared, what is its value in the moon's surface? What is its value in the moon's surface? Okay, so for this particular question, just like as we did in the other one, that's what we're also going to do. So if you look at that equation, we said that G is equals to what? G is equals to what? It's equals to capital G M all over r squared. Okay, so this relationship between acceleration due to gravity and the universal gravitational constant. Now, in this particular question, you are given that for this question, you are given that the radius of the moon ROM is given to us to be 1/4, 1 all over 4 that of the Earth. And you're also given that the mass of the moon, you are also given that mass of the moon is equals to 1 all over 81 that of the mass of the Earth. That is what we are given. Okay, so just as we did in the previous question, we can have that the radius of the Earth to that of the moon is equals to 4. Then also the mass of the Earth to that of the moon is equals to 81. Okay, then the accelerated due to gravity of the moon or the Earth is given to us to be 9.8 meters per second squared. That of the moon is what we are looking for. Alright, so take note of this as we did in the first equation. Now from our equation, we had that G moon will be equal to universal gravitational constant times the mass of the moon all over r moon squared. Okay, then G Earth will be equals to gravitational constant mass of Earth all over r Earth squared. Okay, so now they said what is the value of G in the moon surface? Okay, so you can actually write this as G moon all over G Earth equals to, do that division the way we did in the other equation. So you are going to have G moon, this is G moon, r squared multiplied by that. You are going to divide by this. So when you do this division, when you divide by this particular equation, you are going to have this, that's RS squared all over G ME, mass of Earth. So your G we cancel out, so that in this equation so that you can have that mass of moon all over mass of the Earth multiplied by radius of the Earth squared all over radius of the moon squared. this is also equal to, okay, this is also equals to mass of the moon all over mass of the earth multiplied by radius of the earth all over radius of the moon, all bracket squared. So as we did in the other one, as we did in the previous question, you can bring this together. You have G moon all over G earth is equals to mass of the earth over mass of the moon. Mass of the earth over mass of the moon means it's inverse of 81. Okay, so that will give you 1 all over 81 multiplied by radius of the earth over radius of the moon is 4. Okay, so multiply by 4 squared. 4 squared. Okay, now remember that G earth is given to us with 9.8 meters. So G moon, which is what we're looking for, will be equals to G earth multiplied by 1 over 81 times 4 squared is 16. So if you bring that together, that is 16 over 1. So if you bring this together, you will have that G earth, which is 9.8 multiplied by 16, 9.8 multiplied by 16 divided by 81. Alright, so by the time you solve this out, your G moon will be equals to 1.9 meters per second squared. Alright guys, so I hope this one is also simple to understand. I know it's a lot of process, but it's just for you to be able to decipher the question and then know how to apply the formulas to solve. So okay, that's why I had to go through all these things to make these questions easy for you to solve. So what you need to do is to go through it. If you don't understand the first time, please go through it again and again, and then solve some problems from some other textbooks. You will see the understanding, but it's basically simple. It's just for you to know these particular equations. Once you are able to understand this one, it's just to do some simple mathematical manipulations, and then your answer comes out readily. Okay, so from this question, from this you see that the acceleration due to gravity in the moon is actually less than that of the earth. 9.8 to 1.9. The difference is clear. All right, so thanks. Let's go to your test page. So please, these are questions for you to solve. Try to apply what we have solved before in order for you to solve these problems. Okay, please try your hands on them, check your textbooks, solve more problems on your textbooks, and then look at past questions too. Okay, solve past questions and then you get more understanding. If you have any challenge or any problem, please just don't forget, just go to our WhatsApp page, paste your question there, or put in the comment on the video. We'll look at it and then see how we can assist you to solve any problem that you have in physics. Okay, so this is where we are stopping our video on our class for today. Right, so but before I go, if you have not subscribed to our channel, please, what are you waiting for? Please subscribe to the channel, give us a like, give us a thumbs up, so that whenever we upload a new video, YouTube will notify you. Okay, you can reach us through the WhatsApp number that is showing on your screen. I remain notable Michael. This is Nobleman Science Resource Online. We are here to make physics as simple as possible for you. Okay, so please continue to follow us, share the video with your friends, share it with your colleagues. If you know you have any friend that is in an area where they don't have access to good physics teachers and they have access to Android phone, why don't you just introduce this to them, and then they'll start to learn physics right from the scratch, because we actually started from the scratch. Okay, we've started from the foundation and we'll be building on our knowledge gradually up to this point. So introduce the video, and then you will have done somebody a whole lot of good. Okay, so thank you so much for your time. We appreciate you. We hope to see you in our next class.